I'm trying not to say my catchphrase. Good morning, guys. It is Tuesday the 15th video and our video lesson for today. We are going to be working on physical and chemical properties of matter today. We're trying to keep in mind our overarching question, which is how can the properties of matter change? And so as we're going through today's short lesson, we're really going to be talking about what is a physical property and does it change? Does it go to a solid, a liquid, a gas, or a plasma? And the same thing with those chemical properties of matter. What do they mean? Can they change? Now, when we're thinking about physical properties, we already know that it's what can be seen or measured without it turning into a whole new substance. We talked about that a little bit when we did our vocabulary at the very first lesson. But today they want you to think about it just a little more deeply. It's not going to be any big giant thing. However, you do need to think about when we're talking about a physical property, what does that really mean? In a Learn at School setting, we would be using our textbook to kind of analyze a couple of pictures that are in the book. You have that as an attachment, and you will need to read these two little pages before you go on to answer the questions. However, we're going to hit the high spots right now. And not sure how this is going to show up on the video, but I'm trying, guys. So I'm going to flip around to the Elmo, and it gives that weird kind of distorted look. But I'm hoping that you can get an idea of what they're talking about based on just looking at copper, okay? So here we go. So the first thing that we're going to be looking at is copper. And what are some of these properties of copper? So here we have copper in its most rudimentary form, which means in its rock form. It's being mined out of the earth, and it looks like just a big bundle of rock. But interspersed in that rock are threads of copper. That copper, if I had to describe or tell you what this initial rock looks like, I would say that it looks clumsy to me. It's big, it's bulky, it's got sharp edges around it, that it has metallic or bronzy rust color look to it, spread throughout it. So I'm giving you what can be seen, because that is what a physical property is. It's what can be seen or measured without changing the substance into something totally new. It doesn't mean that the substance can't be changed. It's just not going to be into something that's totally different. Now, the next thing we're going to look at is how all of these pictures are still copper. We've got copper in the rock. We have copper wiring. We have flat copper sheets that have been probably rolled through a machine to get there. And then we've got these little copper balls here to the bottom. Now, every one of these would have a different physical property to describe. So in the wire, I might say that it's malleable, that it's bendable is what that means. That I can take wire, I can move it around, that it is now a ductile, which means it's a good conductor of electricity to go through it, so that you can use it in wiring and houses and things like that. So this wire would have different physical properties than what this big hunk of rock would, okay? Now, if I look at my flat metal is still that bronze-like color. It's flat. It may be, we're going to pretend this is metal. It may be that you can move it around, that you can manipulate it, where the rock is non-manipulated. You can't move it around. It's a solid. Well, this is a little more fluid. I can kind of make it do what I want it to do. Now, when I look at the little copper balls at the bottom here, they have another physical property. They're round, okay? You can roll them around. They're light. They're very easily portable. So when I'm talking about physical properties, all of these things are still copper. However, they all have a distinct look and they all have a distinct purpose. So physical properties are what you can be seen, but they're not going to change into something totally different. Now, when we look at a chemical property of matter, that is a whole new ball game. Chemical properties are where you introduce, I'm gonna kind of get out of this light, is where we are introducing a whole new element to your element so that something brand new is created. And we talked about that with our candle and our wick, how we had a cotton wick inside, and once we lit it, then the wick turned into ash. But really and truly, what we have to think about is, why did the cotton wick catch on fire? It's because it's flammable. Not all things are flammable, which means they can't catch on fire. Aluminum foil is not flammable. So a chemical property that is not, that it's flammable for this, however, it's flammable here. So all of things that we deal with on a day-to-day basis or that are in the universe have different chemical makeups, which means that their chemical properties are different. So I'm not able to catch a rock on fire with a match because it's not flammable. However, if you have rock in a volcano and the temperature is high enough, that rock will liquefy and turn into a lava that then can spew out and then re-solidify later. It's another lesson. I kind of got off on a tangent. So when you start reading on page 371 here in a few moments, when you get to chemical properties, you are going to have this little handy dandy little grid here. And it's going to give you this something. It's going to say, give you the name of the substance. So the very first one on our list is wood. And the physical property of wood is that it does not conduct electricity. No matter what you do to it, it's not going to be able to take ampage and turn lights on. So it's not going to be a good conductor for electricity. However, the chemical property is that it's flammable. That wood will catch on fire. We have iron. Iron is malleable, which means you can bend it. It's you can heat it or warm it and reshape it to what you want. So iron is malleable. But what we are learning is that the chemical property of that is that combined with oxygen, you can get rust. So let's talk about that for just a moment. How many of you have ever had an outside dog on and you kept it chained up? I'm not a fan of that, but some people do. And one of the things, if you have big dogs, is that if you're not careful and you use the same chain over and over and it's always outside, as that rust builds up on those linkages, they will weaken because the rust will eat through the metal and it changes that metal from a strong metal to it will slowly disintegrate, and your dog can pull and eventually break your chain. And so when we talk about how iron is susceptible to rust, That's a true, really statement. If you've ever been digging around in your backyard too, sometimes you'll come across old nails that might have dropped and they are just totally rust covered. Well, one of the things on 371 that you'll see is they've got like this beaker and it looks like yellow liquid in it, and they've got a nail in it. And you can see all these little bubbles coming off of that nail, and it's really a cool thing. And I wish I'd thought about it last night. I know I don't have any rusty nails at home, but if you've got a rusty nail at home, I'm going to tell you an experiment that you need to do. Find a rusty nail or find a rusty chain, a piece. Get some vinegar. Your mom or your mama has some white vinegar somewhere. Pour it in a cup. Drop that nail inside that cup and let it sit for 4 or 5 days. Now, it is going to smell horrible, but set that cup outside where it's not in the house smelling everything up. After about 7 days, go back, take your nail out and run your finger down the nail and see if some of that rust doesn't come off. If it's not coming off really well, soak it some more, because vinegar is reacting with the rust and it will eat the rust away. What the vinegar also does is that it will weaken your metal and it will make your metal brittle. You can bend it. It makes it malleable. If it becomes brittle enough, you can even snap it. So that's a cheap, easy thing you can do at home. So with this list in your book, it's giving you ideas of what their physical properties are and what their chemical properties are. So when we get off of here, right here in a second, I want you to definitely read 370 and 371, paying close attention to all those pictures and the captions or the text features. And that's what captions are. They're text features that go with the reading, because you'll get a lot of really good information from that. Tomorrow is your quiz day. I'm working on that as soon as I get off this video. So make sure that you study and go over the vocabulary this afternoon. You've been doing it daily with your Quizlet. But what you're going to be asked to do is that there are 8 questions that relate to vocabulary, no big deal, and how do you use those? And then your short answer question is going to be an application question, I call it. It's going to give you a question or a scenario, and then how would you answer that using a science concept, okay? So a little bit of application here, but study those vocabulary tonight. In your journals, I'd like you to add physical properties and chemical properties, because remember, everything that's in your journal, you can bet is going to be on a quiz or a test. So at this point, you should have physical property and chemical property added. You would have density and weight, and you would have mass and volume. So we know that those are definitely going to be on the test. So make sure you throw them in there. All right, guys, that's it. You will have reading and questions that go along with this reading as attachments. So get busy. See ya.